I think in the last class we did online, we did heap, min heap or max heap, also called as priority queue. Now, today what we'll do is, we'll quickly wind up stack. Okay, it won't take more than half an hour to, not even half an hour, 15 minutes, we'll know what is a stack. Stack is a very trivial, very simple, very straightforward data structure. Should not take too much to understand. So we'll finish stack, and what I want to emphasize is how do you work with JDBC, because that's an important area, and we will quickly go there, look at one or two sample programs, how to do JDBC. So we will probably be able to explain JDBC today, but play with it next session. It's extremely important that you understand JDBC, because if you understand JDBC well, nobody uses JDBC by the way now. But it helps in understanding how Node.js works with MongoDB or Node.js with MySQL. See, today, very few people used Java at the back end. That time is gone. Okay, it's only while we, as an introductory language or as a also ran computing language, we do it. Today, the predominant language is what? Not Python. Python is only AI. JavaScript. So actually, the language to learn today is JavaScript. But we have, for various reasons, we can't incorporate it into a syllabus, but you need to know that. And also, recruitment exams are still not done in JavaScript. They still prefer either Java or C++ or Python. So that's why we have to live with old languages. But okay, so what we will do is, but these data structures and all are same. The way JavaScript talks to MongoDB, very similar to the way Java talks to MySQL, very similar. Once you understand that basic interaction, you can write an application in either worlds. We can look at stack here first, then we'll look at an example of stack. So if you notice, stack is derived from vector. For a lot of years, vector used to be the de facto data type for list and stack both. But nowadays we use list for list, and we use stack where we need a push and a pop operation. Now the methods in a stack are also very trivial. So the methods on a stack, as you can see, they are very common. Whether the stack is empty or not, can you do a peek in a stack or not? I think you already know what is a peek. Just look at the topmost element of the stack without popping it, without getting rid of it. Then pop, which actually gets the element out. Now pop also returns the element. Peek only looks at the element and gives it. Pop returns that element and also removes it. Then push, push is anyway there. Now the method which you shouldn't use often is search. It's a very slow method, because what it does is it goes through the entire stack from top to bottom looking for a particular element. So as far as possible, forget that there is a method called search on a stack unless it becomes extremely, you can't find another way to solve the problem, then only you should use search. Actually, we should not talk about search at all, because we shouldn't use it. It's very slow, performance is very poor. So the methods you should employ are push, pop, peek, and obviously whether the stack is empty or not. Those are the common methods which you would engage with a stack. Most of these methods are simple enough to understand, and I think we can look at a quick example, Geek for Geeks, how to use a stack. I don't think we even need that, but let's, for sake of completeness, let's do it. So this is the stack class. Yeah, so this is how we use. Okay, very, very simple. Okay, so this is how we create a stack. No, stack, push, yeah. I think we have to look at the main and then go down. Okay, so the way you create a stack is like that. Stack integer, stack is equal to new stack integer. The type of should come. Then the operations, as you can see, are push, pop. You can also do a peek operation. to see what is there at the top of the stack, and obviously you have to print it. And then search is a stupid operation we shouldn't do. So that is it. That's the stack. And use push pop. So push pop here he has written as methods. So we can just look at one of these or two of these. So stack pop, stack push. He's pushing a bunch of integers into the stack. Stack pop. Can we go down? Yeah, he's just removing them in the reverse order, obviously, and printing them. Peek will get you the element at the top of the stack and is displaying it. So I don't think this needs an explanation to understand how a stack works. Okay. So let's pretend we know how to use a stack. Okay. Now what we are going to do is we'll do one application with a stack. I am going to ask you to do an application on a stack. Let's do that application quickly. I hope within 15 minutes you will finish the application and we can move on to discuss JDBs. Okay? So we'll just do one. There are two. We'll leave the second one for you to do at home. One you do now. The first one you do now. We will do the second one later. Or you can do the second one. So just open one. Okay. Yeah. So we just started one. It's called program 1 19722. That is the name of the program. So please give it a shot and we can quickly move to the second one, to the JDBC. If you have an input like that happy, you know what will happen. I think perhaps you have made it out. If you have a uppercase and a lowercase together, you need to get rid of them. So you need to write, so basically this has to be done using a stack. So you have to keep on adding characters to the stack. When a particular situation occurs, you have the peek method. So you should keep peeking at the stack, look at it, what is the topmost element. If it is so that you have an adjacent uppercase, lowercase, you have to get rid of both and move on. And you have to, sometimes it's not just the top two, the next two also may have. So you have to write a while statement, not a if statement. If you write an if statement, you will get only one at one shot. But if you write a while statement, one small while statement will solve the problem. Uppercase adjacent with lowercase, lowercase adjacent with uppercase. So there are some methods to check whether it is upper or lower. They are all available in the character class, or you can look at the ASCII value. But there is this character class which has methods called is upper, is lower. All those methods are available in character class. So you can look at those methods and see whether those methods suit you. Because other option is ASCII value. Is it uppercase, lowercase? I think we will solve. You guys are too slow. This is okay. We'll try and solve. So just those of you can solve, go ahead. But those of you need little help, you can look at the screen. So we will have to import java.util.star because the stack class is part of java.util. So we said import java.util.star, then class test. So now we will write the main. We will write the entire code in a main. So we don't have to call anything. So public static void main. So the only thing we need to do is read the string. That's the only input. So we'll create the scanner object. Then we will read the string. String s is equal to s dot sc dot next line. Next is also fine. It's anyway a string, right? Okay. Now I have to create a stack of, what should the stack be of? It should be a stack of what? Characters, correct? It should be a stack of character. Yeah, everybody agreeing. Okay. So I will create a stack of character. Okay. So call it st is equal to new stack. We created a stack of characters. Now what will we do? Now we have to go through the string one by one, looking at every character. What is going to be our logic? First we are going to check whether the stack is empty or not, right? If the stack is empty, that means there is nothing. What we are going to do? We are going to blindly push the element into the stack, because if it is empty, that's all we have to do. Okay. So, okay. Or when are we going to push elements? When they don't meet a certain condition. So first let's write a while loop to decide when we are not going to push data into the stack, when we are going to pop. When are we going to pop? When the character that when the stack should not be empty. That's the first condition. Because if the stack is empty, I don't have to look anything beyond. So I can just add the element to the stack, isn't it? But if the stack is not empty, then what am I going to do? I am going to examine the top of the stack. How do I examine the top of the stack? Using a peek, right? I am going to look at the top of the stack. I am not going to pop it. If the character at the top of the stack is uppercase and the character I am examining is lowercase, remember one of these things happen, or the other side of the story, isn't it? Either it is capital B already on the stack and I have small b, or I have small b in the stack and now I have capital B. Either of these two cases I need to pop the stack, correct? And move on to the next element. Okay. So if that is the case, I need to write that condition carefully. Okay. Now I am going to try and use an elegant while statement in order to do just that. Let's give it a shot. You need to add little more to it. While stack is not empty, and let's add and. Okay. And okay. First condition to be fulfilled is stack should not be empty, and then we are going to observe the stack, top of the stack, that is the peak, and the character that we are looking at. If one is upper, other is lower, that is they are that reverse, then it signals to me that I need to do something to the stack, that is I have to pop the stack, and I have to keep on doing it till I encounter a situation where this is not true or stack is empty, correct? Okay, so let's write that. Stack.peak gives me a character. Stack.peak, remember, returns a character at the top of the stack because the stack is not empty. If it is uppercase, no, I think you will have to write character is upper. Character dot is upper. If this is upper, who is upper? Okay, is upper, bracket, yeah. st dot peak. So I hope you are understanding what I wrote. If this is upper, I think if you can take that statement out, can you paste into it? I'll write that in Notepad. So while stack is not empty and character is upper st dot peak, and there is one bracket, and character is lower. Okay, we'll change it to character is lower. Okay, s of I, that is the character we are looking at in the string. S dot char at I. st, no, we are not looking at st. We are looking at s. S dot char at I. Okay, I hope at least some of you are understanding what I am writing. What I am saying is, if character is upper st.peak and character is lower at s.char at I. Are you understanding why I wrote this? I am checking whether I have an uppercase character at the top of the stack and I have a lowercase character at the top with me, then I have to do a pop, correct? You have to decide when to do a pop or a push. On a stack you can do, unfortunately or fortunately, one of these two, right? When do we pop, when do we push? Okay. So we are saying character is upper, st.peak. We are picking at the stack, it will give us the topmost character at the stack, and we are saying is lower, the other character. Okay, now I'm going to complicate that expression a little more. What is the other condition for popping? The reverse, right? No, yes. If I have a lower character at the top of the stack and the character I am looking at is upper, then also I should pop, correct? Okay. So one of these two conditions is fulfilled, I have to pop, and stack should not be empty. That is the other. So in order to make that expression work, we'll go after the AND. Go after the AND. Before that, put that in bracket. This and this, sorry, you have to put, I think, 2 brackets. Be careful. See, okay, let me write it down here. What we want to write is, stack should not be empty. Let me write it in English first. Stack should not be empty. This is the first condition. And either character is upper st dot peak and character is lower s dot char at I. This closes and this closes. So this condition, I think we need one more for this so that this gets ANDed together, or now this is to close this, we do this, or the second condition, that is character dot is lower st dot peak and correct character is upper s dot char at I. Yeah, this should close, then this should close. Okay, we have to match the parenthesis carefully. If this condition is true, stack should not be empty, and either this condition, that is the composite of this, or this is a conjunction. This is called a first conjunction, and this is the second conjunction. This is conjunction 1, this is conjunction 2, and this is called a disjunction, correct? So either of these two conjunctions are fulfilled, then we are fine, we can pop. So then we should say st dot pop. That's it. That is our for loop, while loop. Now, either of these two conditions are fulfilled, we should pop. If this is not true, what should we do with that character? Just push it onto the stack, because there is no point taking it out. Okay? So we are going to write this condition. I hope you are understanding what I am trying to write. If you look at your problem, what are we supposed to remove? Adjacent characters when their case are different. Characters should be same, only variation should be in case. So the first one should be lower, second one should be upper, or first one is upper, second one should be lower. Any of these two happen when this kind of adjacency. And remember, if you look at that sample carefully, if I remove these two, why am I writing a while loop? If I remove these two, what may happen is the character that I now see will match with the character which is now on the top of the stack. So I have to continue removing. So that's why the while loop has to be written. If you want to do something throughout, you have to write a while loop. Okay. So let's write this while loop and see whether it works for us. Yeah, you can erase. Yeah, this is the while loop we are trying to build. So let's try and build it there. Okay. So character is upper. We have to be careful with the brackets. No, that, see, you need there, I think 3 if I am not mistaken. Okay. No, you match. Maybe you will be able to see it better. Anybody has got this logic going? We can copy that. Okay, good. What is the other condition? That is also there. Small c and big C. Oh, I didn't see that. So we'll add one more condition. Okay. In your example, so we didn't add that, no? I didn't see it. If 2 CCs are there, no, not that. If both are same, no, you don't have that as a, but do you have that in your test cases? No, happy, no, you are not doing it. No, why are you saying that will happen? Look at happy, no? I am not getting rid of the 2 P's. No, I think we are right. See, look at happy. Only the adjacent P's where the case is different, they are going. When the case is same, we don't take. I thought you meant that. I am sorry. No, in the sample they have given, no? Oh, in the question, okay. No, don't go by the question. Choose 2 adjacent characters that SI is SI is the lowercase letter and SI plus 1 is the same letter but in uppercase. And the other case is, only that you have to check? No, SI and SI plus 1. Oh, the other pair is not needed to be checked. First one should be lowercase, second one should be uppercase. Then we have a simpler thing.
And vice versa also.
And vice versa, where have you written? And vice versa. Okay. No. Why are you getting that doubt? It's vice versa means the other way around. No. And look at the example. Is everybody clear? It has to be lower upper only. Okay. Or upper lower, whatever. Okay. It cannot be same. Yeah. So we are picking up this code. No, we are not done yet. Or is lower, and this should be is upper. Now I am hoping that the brackets are matching, but that you will see only in our editor. Okay, so we'll take this off and put that statement there. Just check whether the brackets are matching. You will see there the color. I can't make out here. First check outer are matching or not. Okay. No, doesn't it show that? It shows no. It's showing you. Though check no. Is it matching or not? This, see, one bracket starts that st dot peak 1 and see the or, put your caret after or, put your cursor after or, put it on that caret, put it on that bracket. Now check where that bracket is matching. that is matching there. But is that okay? Because after that there is the end of that. Okay, I think that part is fine. No, if you are seeing match, that is okay. Okay. Achha, your cursor will tell you whether the matching is correct or not. Okay. Look at it carefully. The bracket matching has to be wisely done. Now, if that is the case, that we have these kind of adjacent characters which is detected from the stack. Now, before I explain rest of the code, let me explain for those of you who are not understanding. Okay, so maybe a brief explanation for those of you who are very slow. What will happen here? H, okay, H stack is empty. So the string, okay, let me write that string here, H A P P P P Y. This is the string. So H comes, stack is empty, gets added. A comes, it looks at the top of the stack, it's not empty, stack is not empty, but this is not matching. This is not upper, this is not lower of the same thing. Okay, this is not lower, this is not upper, there is no pairing. Achha, an easier way to check is, you can make both the characters to upper and check. You don't have to say, you can simplify your logic by saying, I'll convert both the characters to upper and match. But the problem is, equal characters will get eliminated. That is a problem. So what we have written is correct. So the HA, there is no upper lower relationship. So the while loop doesn't go. So after the while loop, we are going to write a push. So A comes and sits into the stack. P and A don't have an upper lower relationship. So capital P also comes and sits in the stack. Now I am on this P, the small p. Now it has an upper lower relationship with this. So what I'll do? I'll pop this. So now my stack becomes H and A, and I am onto this character. I move one character every time. So P, now they don't have an upper lower relationship, so small p. Then I move here, they don't have an upper lower relationship, so again one more p. And then I have Y. Okay, now my stack is going to look like this, whereas the output I am seeking is this. Okay, now what I have to do? My stack will look like this. The Y will be at the end, and there will be two P. So I will pop the stack into a string. So I'll get Y, P, P, A, H. I will reverse it and display the answer. Okay, so that is what I am going to do. Now if you look at this this problem, okay, what will happen? Now first A will go onto the stack because stack is empty. B will also go onto the stack because there is no relationship between B and whoever is at the top of the stack. There is no relationship. So B will also go and sit into the stack. Now I get this second B, which is uppercase. So there is an upper lower relationship, so it will kill this guy, and we'll move on to A. So now in the while loop, what will happen is, it will be like this. Now we'll move on to this A. Again there is an upper lower relationship, so this will go. At this stage the stack will be empty. Now this C will come, it will blindly sit there because stack is empty, and this C will come, and what will it do is, because this C has a upper lower relationship with this, it will kill this guy. Stack will remain empty. I'll pop the stack because the stack is empty. I can look at that and say the answer is an empty string. Okay, so that's how I have to solve this. So you have to be a little bit careful. How do you manage your stack and write the code? It's not difficult. Only thing is, what we are seeing, upper lower relationship should exist with the characters. Then we have to pop the character. If not, we have to push the character, because if there is no upper lower relationship, the new character which we are bringing from the string should come and sit in the stack. Okay, so if this condition is fulfilled, we should do a st.pop. That's all. Such a big condition, but the body of that loop is just pop. And once, I don't know where it starts, okay, so there it ends, and after that, yeah, come down. No, after the while. After the while. What will we do here? What will we do here? This while loop is, we forgot to write one very important part. Okay, what did we forget? We didn't write the outer for loop for picking up characters. Where is our I coming from? We forgot that. So we have to write that for I equal to 0. Int I, y कर सकते, I equal to 0, I less than s dot length, I plus plus, till it is less than length, or length goes up to from 0 to length minus 1. Yeah, that is fine. Okay, while this is going on, this is the while loop. No, after that, after the inner while loop, yeah, we have to push st dot push caret s dot caret I. Yeah, because this will come here when the stack is empty or the character is not matching with the top of the stack. Then it will come here and push the character. Okay. Otherwise, okay. Now we have a problem here. Now it will remain in the while loop, but the I has to increase, no? No, see, we should combine that while loop only. We should add that length also in the while loop. Instead of writing it separate, we should combine that, remove that for. No, in that itself, we have to say I. So first time it will start with I equal to 0, and then we will have to increment the I in any case. Whether you pop or you push, in either case, the I should go up. You remove that. Anyway, there is only one statement which has to execute. No, that while loop is to try only for, no, I think, no, we will, when the while loop is running, see, what we need, what is missing there is I has to increase while this is going on. Okay, so st dot pop and I plus plus, just write I plus plus there. Okay, and okay, then close that bracket, semicolon. So while this is going on, it will keep checking and looking at next characters. If this does not fulfill, then we go to the next character and we again increment I, no? Even after this we have to increment I plus plus, and we have to write a while loop at the top where we say while I less than s dot length. Okay, let's check whether that length. Let's check whether that, open the bracket. That should enclose, it should end at line 19, correct? Okay, will this work? I is 0 while I less than s dot length. If this condition is true, I keep looking at next character and next character, pop and keep looking. So otherwise I push the character I. Am I skipping any character? push the character at I. No. When you come out, what does it mean? Oh, so I have absorbed the character in the loop in the line 16. Now, imagine a situation where we get a character which is not matching. So what happens in that case? It gets pushed into the stack and I increases. That's fine. Is this okay? At the basic level, is this code okay? With the loops, okay? Now just think it to yourself how it will work. You may have a different code, but you should be able to think in these terms also. While I is less than s dot length, we are going to go there. That is, I is going to go from 0 to s of length minus 1, because that's how the indexing happens. Every time we are going to check whether the stack is empty or not. If it is empty, then it doesn't enter the while statement at all, and it straight away pushes the character in the stack and goes for the next character. If it is it's not empty and that condition is matching, then what happens? Then the characters at the top of the stack continue to be popped and I keeps increasing, because this current I in the string has been dealt with because of the pop. We don't do anything with the character. We go and look at the next character. Okay, I think this should be okay. Okay, now what we'll do, we'll not get the answer yet. We'll just print the stack at the end. Okay, yeah, while stack not empty. So we'll build a string builder because then we can append to the stack. No, just create one string builder, because remember, string builder has the ability to get appended. It's mutable. So string builder SB is equal to new string builder. We'll do that, and then we'll say SB dot while stack is not empty, because now there may be all kinds of things in the stack. While stack is not empty, okay, what will we do? We will say SB dot append ST dot pop. Okay, so we'll keep doing it and we'll get SB at this stage. Then that we have to convert it into string and print. So that anyway system.out.println will do. So we will do that. Can you scroll up? Yeah. So we will do that and check whether, now this string will not be the string that the answer wants. It will be the reverse, because we are popping from the stack and putting. So one more reverse may be required, but we'll do that. Let's check out this part first, and then we will check whether what we want. Okay, let's see. There are a bunch of errors. Empty, I think E is small. And okay, let's see whether this corrects a few. No. Is upper also, I think U is small. Carat. Okay, sorry, it's a problem with carat. Carat C is small. Okay, let's see if we get some more errors. So is lower is a problem, then is upper is a problem, and again is upper. I think U is small or what? Okay, is uppercase. We have to change in quite a few places. No, no, there are 2, 3 more places. Lower case, upper case. Okay, let's give it a shot. String builder, yeah. Okay. Okay. Now let's give that string happy. HA, small, big P, small p, PY. Yeah. Do that. Oh, we got a empty stack exception. That is on line 102. Test.java 10. Okay. See that and should be completely fulfilled. Okay. Put one more bracket after that and put one more at the end. Yeah. Okay. Let's try our luck. Now it's coming correct. No. It ate away the A. And it should, A and P are gone. Whereas what should go? Okay, there is a small bug. So we have actually the removing is not happening correctly. When the condition is matching, when it is not matching, or when it is matching, we are removing the wrong guys. Okay. So, okay. So what may be happening? Okay. Now, try one more. Try one more. Some other string. Let's see what's happening. And let's see if you can correct. Okay. So let's try and analyze what perhaps is going wrong. No. We'll see this first, then see. So when we have H, first time it won't go here. So H will go here. Then A will come. A will also not. A will be tested here. So is uppercase st.peak. I am only not sure about the brackets. Is uppercase, this will not be true. What should be true is this, because when you have P and P, first is uppercase, no? This is uppercase. So this thing should have, this is uppercase and this or this. It's popping. Okay, let's run one more case and see what's happening. A is getting pushed or A is not getting pushed. Let's see, no? Let's see one more example. Now let's try something small. Let's try just A, then uppercase A. Okay, let's see what happens. This itself isn't working. So string index out of bounds. This error is coming at line 16. Okay, let's see what's happening on line 16. Line 16, when we are pushing, s dot char at I. Oh, that I, okay. No, I is going beyond. I think discount. We should do, if that is not there, it should do this, no?
Yes, sir, but same I.
So that I, which is that character, if the while loop is encountered, it should not do this.
problem with implementation.
Yeah. So, if we enter the while loop, we are anyway looking at the next character and we are doing it. So, should we increment I at this stage? See, the problem is coming here. st dot push s dot char at. No, wait. See what's happening, as long as that condition is fulfilled, we are going. So when we come out of the stack, the I is not matching, correct? Then only will come out, or is there any other way we can come out? No, it is popping something, but it's not popping the right thing. See, that uppercase P went away. So it is popping, but it's not doing it correctly. I plus plus. Yeah. Anybody wants to provide hints? We are somewhere making a small mistake. See, what we are doing, we are saying I is less than s dot length. Okay. Then we are checking whether that condition is correct or not. So if that, as long as that condition is correct, we are going on popping and going to the next I. Okay. That is, I think, okay. Because we have to look at next time the next I. And once we don't enter into this loop, then the stack may be empty or there may not be a match. So for that character, we are pushing the character at I. Now we will have to think whether our, okay, let's try very small, even small. Let's try one more. Let's run it. Let's try to debug it without, just write one small case, one uppercase. That's all. Acha, that gave error, no? Okay. So in this case, let's see what happened. Okay. No. So what happened? Let's see. No, we'll debug it. People will understand how to debug also. So, yeah, why is this string small a uppercase? Why is it failing? So, if we write small a, the stack is empty. So, it will not go into the while statement at all. It will go into line 16 and push that character. So, we can put a SOP there. After the loop, wherever you are pushing a character, no? Just write SOP, system.out.println. What character should we write? We should write the character right now, s.char at I. S.char at I. Okay. Now just put, to make out, just put 2 hyphens before it. String 2 hyphens so that we know it's coming from there. Put 2 hyphens. Don't put space again. What's happening to our stack? Small a, big A. Okay. So small a has gone onto the stack, yes. So it checked the stack. Now when it did A, okay, go back. So just put, go down. When it met the second condition, that is the big A, it popped and I went up. So when it popped, I again went up. So I should put a condition there that I should not increase I. See, what happened here is, when I increased I went to 2, whereas the I should be 0 and 1. For the character 1, I checked, it is matching, I did a pop, but after that I incremented I. And so just put a condition there, I plus, no. If I less than S dot length S dot length, yeah, then only I should do I plus plus. Looks very ugly. Okay, let's see whether this error goes away. No, again, yeah, same, but why? See, earlier case, I was incrementing. Now, okay, it may take a little while. Now, I less than S dot length, then what will be I now? I will be, no, first time I will be 0. We'll change it to is upper. What's your number? 56. Okay, let's look at this 56, maybe cleaner. We have made it little, no, I should not become 2. I should become 1. Okay, let's see someone's code. Okay, let's see how someone has done it. Okay. Take this off. Okay, let's see someone doing this. Okay, there are no while, that no problem with that. If the stack is empty, then push the character, correct? Else if, the two conditions I guess, S dot peak into integer form is equal to this is upper, no, minus 32 will be, okay, one is upper, other is lower, then or this is upper, that is lower, okay, good. Then we pop, else, yeah, good. Actually, we are also trying to do the same thing, but we have made a mess by writing a while statement. Anyway, good. So we'll just change this, okay, we'll change this code to use is upper and is lower, because we shouldn't, as far as possible, do that minus 32 logic, because that works only with English. With other languages which have an uppercase and a lowercase or some other case, it won't work. So it is better to change it a little bit. So this condition is fine, only thing is broken down. So we will say, correct it carefully, otherwise you will ruin it. Character dot is upper, or better still, copy this code, don't change it. Copy this code into our code and then we'll change it. Let that code remain as it is. Yeah, we'll change this. Now this is good code. Only problem I have is we should just change it to if character is upper case, no? S dot peak and equal to character, we can remove all of that, input dot char at I If this is uppercase, then equal to character dot is lower case. Input dot char at I, remove that minus 32, or this should be is lower character dot is lower s dot peak is lowercase is equal to you can remove that int character dot is upper char at I. I think okay, the rest should be okay. Only thing is we have just changed it to this is fine, pop result, okay, he is printing it anyway reverse, this is good. Okay, now just check whether it runs. That bracket we have to be careful. See, character is uppercase. No, don't put bracket there. See, uppercase, we have to get s dot p. That bracket is uppercase s dot p. No, is uppercase will not help. No, we have to say to uppercase, no? Is we shouldn't say. I think this was the mistake. It should be to upper. We should convert one of them to upper. Did we say is upper or?
Converting to upper.
No. This is to upper. No. Just check the name of the method.
Is upper is for checking, sir.
We are not going to check. We are going to convert. Okay. So, convert is what? To upper, no? We made a mistake there. We shouldn't convert. We should convert to upper. Yeah. No. On character. Just check. We have to say to uppercase. Character dot to uppercase. That bracket. It starts there. Character dot to uppercase. Just see where it ends. No, to uppercase s dot peak, it ends there. Okay, good. Should be equal to character to lowercase. Is uppercase or this is lower. Is okay. We'll put it back to is. We are just checking. Is uppercase. No. Is uppercase will just tell us whether it is uppercase or not. No. Is it uppercase or is it lowercase? That is all it will check. If this is upper, that is lower. No, then we have to check whether they are equal or not, no? No. We are checking. See, is uppercase is a Boolean value. We have to check the value. Now, I think we'll leave it untouched to what he is because we have to write more logic. We have to first check Whether, okay, you are using is upper? Okay, good. This guy is picking up fast. Okay, let's see his code. Good, good. Excellent, in fact. That's how it should be. Let's see the code with is upper. Okay. Let's check how he has done it. Good. Yeah, it gets a little more complicated, but it's fine. Character to lowercase s dot peak, that is whatever is there that is getting converted to lowercase, should be equal to character to lowercase. Good. Input. So both you are converting to lowercase, which is fine, and character is uppercase. If both are uppercase, both are lower, no. See, the tricky part is, it's not like that. I don't know, I have to look at the logic. See, first we have to check whether it is upper or lower. Then we have to check, is the case reverse? So, if one of them is upper, other one of them is lower, and they should be equal after conversion, then the code becomes correct. If you are using is lower. See, is lowercase will only tell us whether the character is lowercase or not. It will not tell whether that, what is the value of that character.
This one he changed it to uppercase and lowercase.
Is it one is upper, other is lower, or
he's changed
okay. No, you are not converting. Yeah. No, this will work. This is good. Else if he is converting both the characters to lowercase, so that means the characters are same. Either it is small p, upper key p, or vice versa, or both may be same case at this point. So then another check you have to do is, one should be lowercase, the other should be uppercase. I think that is what is a check after that. Can you come down? Yeah, this is a check. See, first comparison is else if, the line above, character dot lowercase s dot peak. So that equal to character dot lowercase the caret I. This is a good check, whether both are p's, both are a's, whatever they are. That is first. Then else if, if that is there, and there is an and there, good and, okay, come down. Now, what is the check there? One should be uppercase, the other should be lowercase. So, is uppercase the first letter? Actually, there should not be an equal. Okay. See, one of them should be uppercase and the other one should be lowercase. There should be an and in between. Okay. It should not be equal. Okay. Or what you are saying is both are true. Okay. So this returns, no, this is also fine actually, but a better way to do is this should be uppercase and that should be lowercase. Okay. Or there is one more or, this together gets ANDed with that, or this is lowercase and that is uppercase. Okay. That is okay. This is fine because you are checking for the truth value of this, but you are not comparing. Both should be true. Okay. This should be lowercase, that should be uppercase, or this should be uppercase, that should be lowercase. If both of them are true, then what is happening? Okay. If this if condition is true, we are popping, else we are pushing. Okay. This is fine. Now, what we were doing wrong, what I wrote earlier, what was the mistake? Now, I'll tell you the first mistake. Mistake was, I tried to put too many things in one while loop. I shouldn't do that. This is far cleaner, where, can you come left? Yeah. Now there is a lesson to be learned there. See, I was writing everything in one while loop. So, if the stack is empty, you just add to the stack, you don't have to do anything. Else if the second condition, this is a complicated condition, where we have to write that. Else, you push the character to the stack. Okay? So this is far cleaner than the earlier versions. Okay, then coming down, we go to the result, make it empty, and this is to do the reverse. While the stack is empty, keep concatenating the result to the initial values, right? Whatever you have got so far, you concatenate to what you are getting now. Or you can do like our string builder, empty the stack, reverse it, and print it. Okay, we can try one more. Okay, now that we have looked at the stack somewhat, we'll do one more. Okay, we'll enable this. Yeah, we enabled the second one. This is also on stack. I thought we could do JDBC, but doesn't matter. This is also good. And I like some of you are doing good stuff. That first question 646. Sai Kiran. Oh. Last one. Yeah, this is someone else's code. Let's see what. No, I have no problem with this. Only problem is I don't like that 32. Okay. Yeah, the difference, no, it's okay, good actually, where you are checking if it is uppercase and lowercase, the difference is 32. But is it always like that? No, that works only with English. See, the problem, I have nothing against, he also wrote initially, I think, using 32, right? I have no problem with that. The problem is, what happens is, when we go change the locale, where languages are different, it is not language neutral code. 32 will work only for ASCII, not for any other language. Now you'll ask, are there many languages which have uppercase, lowercase? That is besides the point. The point is, as far as possible, no, I am not saying you should not use. As far as possible, as a matter of policy, you should not use this 32 business. Because 32 ties you to English. Of course, if the question is crystal clear that English is the language, then no doubt. But as far as possible, try to write language neutral code. Okay? This will work because the uppercase and lowercase always will differ by 32. But you know the problem is, okay, the problem with that approach, one, if there is some special character, there are, see, not just ASCII characters. There is this hash, space, all these characters if I put, they will also match. See, where are we guaranteeing that the ASCII value is only English lowercase, English character. Even if you use hash in the ASCII set only, and let's say space, I don't know, but there could be a difference with some other character of 32. So it's risky. Are you getting what I'm saying? Don't, as far as possible, don't. Oh, somebody solved it already. The two characters should be equal for you to remove. Huh? And keep removing till your things are empty. Here, don't make the mistake that I made. If the stack is empty, what you should do? Just write an if statement and push it into the stack. And your while condition should check what? The value at the top of the stack, that is peak. If it is equal to the character that you have in hand, you pop. Else, push. Write a if. while has to be written, it has to be written properly. Okay. 17 finished, good.
Same code, no sir, almost.
Yeah, it's by and large the same story. And one outer while loop. Okay, I think we are running out of time, so I'll look at the solution. Yeah, the solution is simple. If you look at the previous thing, it is just an extension of that. What do? You write a while loop to go to the end of the string, and at every character you check. If your stack is empty, you have no other option. Push the element into the stack. Otherwise, check whether the element at the top of the stack, that is as peak, equal to the character you have at hand. If it is so, pop it. Else what? Just add it to the stack. Okay. So I think we will pick one solution. Bigger. Okay. So here we go. So a character stack, empty string B, and line 61 is where the loop starts. For int I equal to 0, I less than h dot length, I plus plus. If P is the stack. If P is empty, don't do anything. Just push the character into the stack. Else, check the top of the stack. P dot peak is equal to h dot char at I. If so, pop and don't go further. You do continue. Anyway, there is an else, so it doesn't matter. Okay, and else P dot push h dot char at I, and end of the story. So this goes on, and at the end of it, you empty the stack in the reverse order. So whatever is coming now gets in the beginning, and whatever is there already gets at the end. Okay. So so that gets it, that's how you print a stack, so that it comes in the correct order. Or you can use a string builder, reverse it and add it. Okay, so that I think is the solution, so which is fine. It's just very close to what we just did. In fact, less complicated than what we just did. Okay. Okay, so we will stop here for today. We could have done a few more, but we don't have them. Okay, so we'll stop here. Next session we'll do JDBC. Now what we are doing is, on the telescope we are creating a private instance for each one of you, so that you can insert, you can delete, you can query. Otherwise, if you use a single instance, everybody's data will collide. So each one will have a SQL instance. So that will take a little while, so we will do it by next session.